Okay, let's go.
Have you ever wondered what are the practical limitations of the large language model like ChatGPT? Or how large language models are evolving and improving as we speak? Can you imagine that a chatbot installed on your desktop challenges the one deployed in the powerful servers of the cloud? Why is this newly released LLM WizardLM gaining so much popularity? If all these questions come to your mind, then you have landed on the right video. We will discuss in depth about the novel approach which is gaining traction in the research community. We have tested it, researched it thoroughly, against several models, and our in-house expert Tom is here today to share his insights with us. He will provide a simple enough explanation about this revolution that is happening quietly. Please welcome Tom, our very own prompt engineer.
Thank you for having me, Trisha. It's a pleasure to be here.
So Tom, can you tell us, we already have ChatGPT. What is the need to create WizardLM and what motivated the researchers to create it?
The language model GPT-4 behind ChatGPT can write anything from tweets to essays. It's pretty amazing, but it has one big problem. Big language models struggle with tough tasks like math, code, reasoning, and complicated data formats. This has been highlighted by many researchers already by showcasing several prompts, use cases, etc. Have a look at this example of finding a prime number. GPT-4 messed up this problem. It knew how to pick 3 numbers and stick them together, but it didn't think ahead about which numbers to pick. It didn't pay attention to the last sentence of the prompt that said it had to be a prime number. It just followed a simple formula. Do something, then do something else with outcome. That's not how you solve this problem. You need to plan ahead. If you're feeling curious and want to learn more about this stuff, you should check out this article by Stefan Wolfram. He's a genius who knows a lot about AI and computation. He's also the creator of Wolfram Vertical Bar Alpha, a powerful tool that can answer almost any computational question you can think of. To improve the performance of large language models, the instruction data for training data needs to be of various difficulty levels. And ChatGPT rely upon human annotators to produce this instruction set. And this makes the whole annotating process is extremely expensive and time-consuming. On the other hand, the difficulty level distribution of human-created instructions is skewed towards being easy or moderate, with fewer difficult ones. Well, you could spend hours and hours creating instruction data with different levels of difficulty. However, the larger the model, the more difficult and time-consuming it is to train. We realized that one of the key factors that affects the performance of Llama is the quality and quantity of the instruction data that it is trained on. Instruction data are examples of natural language instructions paired with their expected outputs. For example, an instruction could be, write a poem about love, and the output could be a poem that expresses love. The problem is that creating such instruction data manually is very time-consuming and labor-intensive. Moreover, humans may struggle to produce high-complexity instructions that challenge the model's abilities.
So, effectively, you're saying that human intellect, time and training is a bottleneck in training high-quality instruction data sets. So how can we solve this problem?
Get ready to be spellbound by the power of WizardLM, the instruction-following language model using the Evol-Instruct method. The magic trick behind WizardLM is a new method called Evol-Instruct. Instead of relying on humans to create instructions, this method uses large language models to automatically produce open domain instructions of varying difficulty levels. It's like starting with a basic spell and using the Evol-Instruct method to upgrade it into more complex spells. The instructions are mixed together to fine-tune the language model, and voila! WizardLM is born. Despite having only 7 billion parameters, which is small in wizarding terms, the results are impressive and rival those of much larger models. With just 70,000 instruction-following data generated from the Evol-Instruct method, WizardLM is ready to take on much larger models.
Wow, that sounds fantastic. Can you explain this Evol-Instruct method a bit more in detail?
Evol-Instruct uses a simple statement like 1 plus 1 equals 2 as a starting point, and rewrites its existing instructions step by step into more complex ones. You can pause the video and analyze this diagram carefully, or read about it in the research paper linked in description. I could think of another example. Take an instruction like, write a poem about love, and rewrite it into, write a sonnet about love with a rhyme scheme of Sonnet 18 by William Shakespeare. Then it can rewrite it again into, write a sonnet about love with a rhyme scheme of Sonnet 18 by William Shakespeare, and use metaphors related to nature, and so on. Evol-Instruct uses several techniques to rewrite instructions. It uses specification to add more details or constraints to the instruction. For example, it can specify the genre, format, length, style, or topic of the output. Second, it uses a combination to merge two or more instructions into one. For example, it can combine write a poem about love and write a poem about nature into write a poem about love and nature. Third, it uses transformation to change the modality or domain of the instruction. For example, it can transform write a poem about love into draw a picture of love or sing a song about love. At one point when this instruction goes beyond useful, the method triggers elimination process, and that particular instruction is dropped out of the database.
That's very impressive. One last point now. How do you evaluate the quality and complexity of the training instructions generated by Evol-Instruct?
Very good question. We use several metrics to measure the quality and complexity of the instructions. Quality refers to how well the instruction is written and how clear and coherent it is. Complexity refers to how difficult or challenging the instruction is for Llama to follow. We use metrics such as readability score, lexical diversity score, and task difficulty score. This figure 3 here illustrates the distribution of the instances and skills in our test set. Our test set consists of 218 instances, each of which is an instruction for a specific skill. Figure 4 shows how the difficulty and complexity of the test data vary across different instances. Our test data has a more uniform distribution, meaning that it contains instructions with different levels of difficulty and complexity. We also conduct human evaluations to compare the instructions generated by Evol-Instruct with those created by humans. What are the results of this evaluation, you may ask? And the short answer is that the results are very encouraging. We find that Evol-Instruct can generate instructions that are superior to human-created ones in terms of quality and complexity. We also find that Evol-Instruct can cover a wide range of domains and tasks, such as writing, drawing, coding, math, logic, trivia, and more. We find that WizardLM outperforms ChatGPT on most metrics and tasks, especially across the higher complexity level.
Wow, but you know what, it sounds familiar to me. I think we have witnessed something similar in chess-playing computers' evolution. In fact, I want to show you a short snippet from the Netflix series, which talks about the AlphaZero, a special computer program that would play against each other. Here is the short clip from the series explained.
And in 2017, a new kind of chess player took the world by storm. Its name was AlphaZero, and it wasn't a supercomputer. It could only consider a tiny fraction of the moves of the mightiest chess engines. But it had been taught very differently.
AlphaZero meant zero human knowledge.
It was just given the rules, and then it had played itself over and over and over again.
44 million games at lightning fast speed against itself. At first, because it was random, quite a lot of the games wouldn't even reach any conclusion because it wouldn't know how to checkmate, for example. But by chance, some of the games did reach a conclusion. So it would look at the moves on the winning side and try and play a bit more like that. In 9 hours of training, it learned kind of the whole of human chess history.
The research community is excited about this development and see this as an evolution of the large language model's training. In the near future, we hope to see several smaller dedicated models using this approach in dedicated domains, be it education, medicine, pharma, or business. It becomes even more important because it's a relatively small model and possibility to run it in dedicated deployments on personal computers, making it practical for day-to-day usage. and making language models truly democratized and accessible. With this, we can conclude our session today. Thanks a lot, Tom. And thank you to you for joining, and we hope you liked our effort. Bye.